Hello, science fans. Today we're diving into the wonderful world of water. Water is everywhere. It's in rivers, lakes, even underground. Scientists and engineers need to understand how water moves across the land. Why? Because it helps us predict floods, manage our water supply, build safer cities. To do this, we use something called a hydrologic model. Think of a model as a scientific crystal ball. It's a computer program that uses math and science to simulate how rain turns into river flow. It helps us see what might happen in the future. That is incredibly cool and very important for keeping everyone safe and sound. But here's the thing. There isn't just one type of model. There are many. Choosing the right one is a huge part of the scientific process. This is called model selection. Imagine you have a toolbox. You wouldn't use a hammer to tighten a screw, would you? Of course not. You'd choose a screwdriver. Model selection is just like that. It's about picking the perfect scientific tool for the specific question you're trying to answer about water. Making the right choice is critical. A wrong model can give you a wrong answer. In the world of flood prediction, a wrong answer can have very serious consequences. The importance of good model selection can't be overstated. It is the foundation of any good study about water. When we choose a model, we make many decisions about how we represent the real world inside a computer. Will we focus on the big picture or zoom in on tiny details? Do we have enough information to build a super complex model, or should we stick with something simpler? These questions are at the heart of the process. Getting it right means our predictions will be more reliable, our water management plans more effective, and our understanding of our planet much clearer. So how do we make these big decisions? It's not a random guess. It's a careful, thoughtful process based on evidence and goals. We look at what we want to achieve, what information we have, and the unique features of the land we are studying. It's a bit like being a detective, gathering clues to solve the mystery of where the water will go. Throughout this essay, we're going to explore how scientists use powerful tools like ArcMap and HEC-HMS to select and build these amazing models. It's science in action, so let's get started. Let's break down the main types of models. First, we have empirical models. These are the simplest kind. They are based on observations and direct relationships, often using statistics. Think of it like this. Observe that 1 inch rain, river rises 2 feet. A simple rule. That's an empirical model. Next, conceptual models. A step up in complexity. Watershed as connected tanks or reservoirs, bucket equals sign soil. Rain fills the bucket. Some water soaks deeper. Another bucket, infiltration. Some evaporates. When full, the bucket overflows. Runoff. Simplified physical processes represented conceptually. Example, SCS curve number in HEC-HMS. Uses a curve number to estimate runoff from soil type and land use. Next, physically based mechanistic models. Most complex and data-hungry. They solve fundamental physics, for example, Saint Venant equations for channel flow. Watershed divided into a grid of tiny cells. Flow computed between cells. Provide high detail on water location and velocity. Powerful but require lots of high-quality data and massive computing power. So which one is best? Model selection. There is no single best model. Choice depends on goal, data, resources, science. It's all connected. This is where the real fun begins. We use software to bring our models to life. A program called ArcMap, or its newer sibling, ArcGIS Pro. It's a geographic information system, or GIS, that lets us create, view, and analyze maps of our watershed. The first step in ArcMap is often processing our digital elevation model, or DM. The DEM is a three-dimensional map of the ground. We use tools like HEC-GOMS. These tools automatically figure out where the streams are and divide the landscape into smaller watersheds or subbasins. This creates the skeleton for our hydrologic model. Once we've prepared our watershed data in ArcMap, we export it to a program like HEC-HMS, the Hydrologic Modeling System. HEC-HMS is the engine that simulates the rainfall runoff process. Inside HEC-HMS, we continue the model selection process. For each subbasin, we have to choose specific methods for each part of the hydrologic cycle. After setting up the whole model, the crucial final step is calibration and validation. This process ensures our scientific crystal ball is clear and trustworthy.